1, 2, 1, 2. Hi everyone, my name is Kristaps and I would like to talk today about core animation and how to tame this brilliant and sometimes overlooked framework. But firstly, why there is tame in my talk's title and what did this actually mean? I got inspired about this word from book Little Prince. It's a really great book for grown-ups explaining what children feel. And it's really nice exercise, really good one for our imagination. And in this book, Little Prince wanted to tame a fox. But Fox explained him, if you tame me, then we will need one another. So during this talk, we'll try to tame core animation, because it's very wild and powerful animal, but it's really hard to tame. But once you do it, you cannot live without it. And here is a little bit about me. I have more than 15 years experience in IT field in various things like building Oracle databases, web apps, web systems, and so on. But I started to work with iOS ever since it came out. And back then, actually, it was iPhone OS. And my daily tasks now are about Swift developments, which includes iOS, tvOS, macOS, watchOS, now iPadOS, and some server-side Swift here and there as well. I love open source and help to maintain multiple libraries like RX Animated, WebSockets library Starscream, GraphQL, Apollo, and many more. And I'm involved in Swift Weekly Brief newsletter, where we deliver news about what's happening in Swift open source language, in community, right to your inbox. And it's actually bi-weekly, not weekly, but that's the longer story. And I have stickers with me, so if you want these stickers, come and grab me after this talk. And if you haven't signed up for this newsletter, search after my talk, Swift Weekly Brief. It's really awesome. By day, I run my own company called Qminder, where I'm one of the founder and Swift developer there. And it's a smart queue management system where we transform waiting lines, this kind of awful experience, in something much nicer. So we give opportunities to our clients and means to engage with their customers using Apple devices like iPads, iPhones, Apple TVs, and more. And we help them to serve millions of visitors every day, like names like AT&T, Verizon, Financial Times, Comcast, and more. It's always hard to start presentations, so let me start with a small story. This is my cat. His name is Mr. Byte. We can call him Kilobyte now because he's much bigger. And I really like to play with him and tame him, but training Mr. Byte, it's a really hard task, and he doesn't always want to do what from the first time. So it's similar with core animation, so sometimes it takes quite many iterations to get the outcome that you really wanted. One day my designer came to me and presented this brilliant idea to create background animation for our Apple TV application. And at first I was thinking, yeah, it should be easy, right? Because I had some experience with UI view animations, and like, how hard can it be? But later in this presentation, I will share my journey, how I did it. And here is Mr. Byte enjoying CA basic animation. And here is great quote by Sarush Kanlu. He's a really good participant in our community. And he said about iOS animations that animations in iOS are easy, except when they are not. So this is exactly how I felt when my designer came to me and presented this idea to make for our Apple TV application. So easy things are relatively simple, but when you need something more, something sophisticated, then it gets really tricky. So my goal today is to talk about core animation, a small introduction about this framework. Then we talk only about path property animation. And then I will share my journey, how I did the task what my designer wanted to create. And a small disclaimer, I'm not going to talk today about SwiftUI. First of all, I'm not so knowledgeable about it yet. And I think SwiftUI is great. And if you want to check out more about SwiftUI and animations, there is a great talk by Chris Eidhoff from FrenchKit. So go and check it out. It's in YouTube. And Paul Hudson from Hacking with Swift is running really great initiative, 100 days in SwiftUI. So these two resources are really great to start with SwiftUI. And here is Mr. Byte enjoying article by Chris Eidhoff. Animations in macOS has been an important role since beginning. So most likely you have seen this genie effect when you minimize the window back to the dock, and Apple integrates animations in their operating systems, apps all over the place, and it's becoming so commonplace that users are starting to expect it. Like if there are no animations, like what's happening should be there. But what is animation in the end? Animation actually is just change in value or state over time. So if you look closely at this cat animation, then we can see at first cat slides nicely on the x-axis, so that is value change. And then in the end, cat fades out, so that is a state change. But what is core animation? Core animation is a framework which helps us to build powerful animated user interfaces. And by the way, inside Apple, in the beginning, it was LayerKit, so that was the code name, because it heavily relates on layer concept. And first, it was presented in August 7, 2006 in WWDC. So that was still time when you could think 10 times if you want to buy a ticket and go there, and that was in August. So 13 years ago, so quite a long time ago, so it's quite old framework. And it was released in macOS 10.5 Leopard. And creator for this framework was John Harper. So he later joined Facebook, and I discovered that he joined Apple, I think 1 or 2 years ago, and maybe he's behind SwiftUI animations, but who knows. And just recently, one of my friends, she passed me a really great article about 10 fascinating things in iPhone and iOS, and I was checking out, and one thing I particularly checked that there was about core animation, and there was another engineer called Bas Ording who moved core animation to the whole next level. So he's actually behind this scrolling effect. When you scroll down and it nicely bounces. So it was inspired by 80s video games, Pac-Man and Donkey Kong. But I would like to point out that core animation was presented in Macworld 2007. So that was the conference where the first iPhone was ever presented. And when Steve Jobs unveiled this remarkable device, he specifically said that it runs stripped-down version of macOS 10. And we had core animation since the beginning. But what is core animation definition? I was looking for good definition in the web, and either they were more complex, I didn't get it, or like it didn't make sense. But then I actually went to Apple official documentation, and unlike other things, for core animation, Apple documentation is quite good. So we can break down that core animation provides us high frame rates to make really nice animations without burdening the CPU. So actually we're not slowing down our apps. But let's start with some clarifications here. So is core animation same as UI view animations? And the answer, of course, is no. That with view animations we can make only animate only view properties, not layer properties. And we nailed it. And once I wanted to animate corner radius over time. So I wrote this code, and nothing happened. It just jumped to the new value, and I was thinking like, why it's not working? And then I realized that I want to animate with UI view animations layer properties. So with UI view animations, these are more lightweight animations. We can call them like more like stock animations. But when you want something more, then you go to the layer level. And corner radius is a layer property. So we need to go to the core animation for that. Another technology we need to discuss today is core graphics. Core graphics is using CPU power for rendering stuff on the screen. So actually it's more pixelized perfect than core animation. But thing here is that as core animation is using, core graphics is using CPU, then it can be slower on older devices. But the good thing here is that you can use core graphics to draw stuff on the screen, and then core animation to animate what you have drawn. Core animation is deeply integrated in iOS stack and macOS as well. So since we're using AppKit or UIKit, then we're using core animation under the hood, even not knowing about it. And it's using Metal, core graphics, and the actual hardware underneath. But so in the end, what is core animation? It's a COCO framework which helps us to build responsible. It's responsible for building animations for cross-platform like iOS, macOS, and tvOS. And it's really great way to do it. But there is one trick about watchOS, that it's not officially supported for watchOS. But we have in community fellow Spelunker Guy Rambo, and I have talked with him. So he has found some ways how to do it on watchOS. So if you want to know more, you can either ask me or ask him directly, and he's willing to share more about it because he loves animations. And it's hardware accelerated by GPU, so it actually runs on separate process. So we are not slowing down our applications, so we can easily use core animation for our animations. And when building animations with core animation, we need to think about two things: time of completion and all the intermediate frames to get to the end of the animation. Because here, core animation will drop all the intermediate frames to rather finish animation on time than make it longer. And here, how this animation will perform on device, you can actually see only on device. You cannot see from simulator, because there are many aspects involved, like what's the system load, graphics hardware capabilities, and many more. So you just tell to the UI view window what do you want to animate, and core animation will do the heavy work, and that's it. But to figure out animation behavior, core animation uses interpolation method. So to plot out points how this animation will perform. So if you want to move one shape from one point to another, then it calculates how the animation will make it on the screen. So the default is the core animation, basic animation, which is basically linear interpolation between start of the animation and end of animation. Math for this interpolation method is quite tricky and tedious. You can go deeper and you can make your own interpolation approaches, but I think that these built-in ones are quite sufficient, at least for 90% of the work. At least for me, it has been. And typical refresh rate for our screens is 60 frames per second. Okay, now there is this new iPad which has 120, but for simplicity reasons, let's talk about 60 frames per second. So if you want to animate this rectangle from one point to another in quarter of a second, so 0.25 seconds. So that means if you have 60 frames per second refresh rate, there are 15 locations together, and that is also start and end of the location, so 13 locations in between for this animation. And we aren't restricted only for this straight line animation interpolation type. We have multiple ones for ore disposal, and you can see that how they perform here on the screen. So there are multiple ones like default, ease in, ease out, and linear one. And we can make our own interpolation types, but in my experience, like for most of the cases, these are quite good. But there are some tools in the internet, so you can even generate Swift code and use if you want to really nail down this interpolation type. But how to do it from code? How to set this interpolation method? So once we create our animation, there is timing function property, which is interpolation type. And then we need to create CA media timing function object. And we can use enums now. Before we had to type stringly, and that was quite error prone. But now we can use enums in Swift, and it's really great. And here you can see all these types are in the enum for ore disposal. And next thing I want to talk about is animation types, and I want to mention 3 here. So first is basic animation, so that is single keyframe animation. Then there is keyframe animation, so we can specify for each of the keyframe how we want to animate. But it's whole separate talk itself, so I'm not going to talk more about it today. And then third one is grouped animations, so we can group multiple animations together. So let's say we want to animate a rectangle from one point to another, then we want that it fades out, fades in again, then animate to another point, so we can group these animations together and work as one animation and set the properties. And here is a little side note for all of us that actually CA layers, all the UI views are backed by CA layers. So if you want more flexibility for animations, then we can go one layer deeper. And for instance, set the corner radius. That's one of the well-known example in UIKit. Core animation is based on layer concept, and that is actually two-dimensional surface in two-dimensional space. But we can achieve quite remarkable effects in three-dimensional kind of approach. So this example is cover flow from original iPhone. So these covers are nicely animated and skewed in 3D space. But yeah, it's achieved with just in the two-dimensional space, so there is no depth. And later this approach was adopted in macOS, in Finder, in as well, so you can see the covers there. And to understand more about views and layers, so let's break it down. So views, on one hand, they are more complex. So you can use auto layout to lay them on the screen. So more complex, I mean there are more classes for ore disposal, and you can create your own as well. So there are like buttons, views, and whatnot. And they can receive user interactions like gestures, pinches, clicks, and so forth. But they are CPU powered, so it happens on the main thread. So if you don't draw this on the main thread, then something funky can happen. Layers, on the other hand, they are more restricted, so there are not so many classes we can subclass and use. And there is no responder chain, so no real user interaction. And they are drawn on the screen using GPU on separate thread. And CA, I want to talk about CA shape layer. So that is specialized subclass of CA layer. So you can use this class to draw shapes on the screen using vectors. So in this example, a rectangle, you can draw using 4 vectors on the screen. And then you can set the line width, fill color, and many other properties. So let's check it out how it's done from the code. So here is example how we can draw a triangle on the screen. So first we need to create Bezier path. Then we move to the starting point, and then we move to the next point, and we draw 3 vectors in the end. And in the end, we need to close the Bezier path. I would advise to do it, otherwise some weird things can happen. At least it happened for me. So it's a good way to close once you have finished with the drawing. And then we create CA shape layer. And then we set the path, the UI Bezier path, what we created. And then we can set line width, fill color, and many other properties. And then we just add the layer as a sublayer, and then it appears on the screen. And next topic I want to talk is path animations, and that is far most powerful complex aspects of CA shape layer. And path animations allow us to morph from one shape to another. So let's say we want to animate from triangle to rectangle in this example. And if it's done carefully, the animations look really nice. Unlike here. Here it looks quite awful and unnatural. And why it is like that? Because these two shapes are not using same amount of points. And even Apple documentation is warning about us that if we use shapes with different count of points, then algorithm is confused and doesn't know what to do. So it interpolates the closest point. So how we can fix it? We need to create these two shapes with same amount of points. So here the sides of triangle is moving up, and the animation looks more natural, more nicer than the previous one. And how we can do it from the code is that we need to create our path animation. So that is CA basic animation, and we can use key paths. So that's a really cool feature of Swift. So we can reference to what property we want to actually animate. So previously it was stringly typed, and again it was more error prone. Then we need to set to what value we want to animate. So in this example, we want to animate to triangle. And then we can set multiple properties like duration, what's the timing function, the interpolation method, is it outer verse, animating back and forth, and more. And then we just add to our shape layer, and we need to set the key. It's a good way to do it, so we can reference in the future. So once the animation has finished, so we can catch the block, or it's interrupted, so we can catch it. And we can group multiple animations together. So let's say we want to animate from triangle to rectangle, and then back to another triangle. And how we can do it from the code is that at first we need to create animation group. So it's CA animation group object. And here is property animations. So that is an array which consists of all the animations we want to create, want to perform. And here take in consideration that you need to set begin time for each of the animation if you want that the animations happen one after another. Otherwise, they will start right away, all the animations. So if that's the case, then of course, but here's more caveat. And then we can set properties as we did for this simple animation. So we combine as one animation this group. And in this part of my talk, I will focus on my journey, how I built the background animation for the Apple TV application. So you can see these triangles are animating slowly and creating this nice lava effect. And as everything cool has to have a name, so I'm calling it animating lava triangles. And this idea came from this lava lamp. So maybe you have seen, it's a really nice calming effect, especially when you are waiting in line. So that's in general quite awful experience. So how does it work is that this liquid absorbs heat and it moves slowly up and making this lava lamp effect. And this was my initial drawing board where I started. So there were 30 different triangles and 24 different points combining these triangles together. Some of these points are out of the screen, so there was no space to put them. And trust me, I spent enormous time to figure out how I can build this animation, what my designer wanted to build. And I even visited CocoaPod's labs in Artsy in New York, and there were like 20 different developers figuring out how we can do it. And when I left this event, Ash Furrow and Orta Therox, who are really great people in our community, told me that at first they wished me luck to do it because it was not clear back then how it can be even possible. And then they said that once you do it, share with the community. So that's why I'm here. And what I came up to was to use Archimedean spiral for animate each of these points. So Archimedean spiral is arithmetical spiral. So it creates these locus points moving from one fixed point away with a fixed velocity. And you can see this Archimedean spiral also in nature, like snails, for instance, or in architecture, like these stairs. Or even this example in Berlin, this Reichstag building, this glass dome, there are stairs going up, and that is built Archimedean spiral in mind. And here is an example from Norway company Snohetta. I hope I'm not butchering the name, but it's going to build Shanghai Grand Opera House with this spiral idea. Math here was not so tricky, but there was one particular thing I have had to fix was coordinate conversion. So everything in iOS happens in Cartesian coordinates, so x and y axis. But using these Archimedean spirals and other spirals, you're using polar coordinates. So that means from one fixed point, the distance and the angle from x-axis. I won't go deeply in the math problems, but it was relatively simple, but that was the problem I had to solve. And to understand more how I can plot these points on the screen, of course I went to Swiss playgrounds when it's not crashing. And I plotted out these points, and I came up to that I can use 500 different points differently on the screen, and that could be more or less sufficient. So here is an example how these points would look like on the screen. But how it goes all together for this animation, what I needed to do. So at first I'm using core graphics to draw all these triangles on the screen. And why core graphics is that we need to support different colors for different clients. So for different clients, these are not green, so they are different colors. So after the drawing is done with core graphics, then I need to calculate all the animations. And as you can see, these points are moving clockwise or counterclockwise with different radius and differently like skewed. And so it makes this nice lava lamp effect. Otherwise, if they would move in the same direction, same radius, then everyone would go mad or something. And I open sourced this project by GitHub, so if you want to check it out, how I did the calculations and everything, or you have some suggestions, then it's up there, so you can use it or check it out. You can take a picture if you want. And experimenting with animations, it's quite tricky and tedious, especially if you want to do from the code. So there are great apps for our disposal. Me personally, I like the most Kite Compositor. So we can call it's Sketch for core animation, and it's really great when you want to experiment how to animate something. And the best part is that you can export even Swift code or Objective code as well, if you want. And there are many more, like Flow, Haiku, Sketch with Anima plugin, but yeah, I think the best one here is Kite Compositor, because it's really niche for core animation purposes. And quite lately, I found out there is really great plugin. Sadly, I didn't find it earlier. It's called Spiral. So if you want, if you need to generate something on the in the sketch using vectors, these spirals, Archimedean spiral and other spirals, it's really great plugin. Sometimes it crashes, but mostly it does work. So yeah, so if you need something this specific, then there's plugin for that. And to wrap up everything, I have a couple of conclusions about core animation and animations itself. So first is that we really need to know when it's enough, like when it's too much. And a couple of months ago, we removed one animation from our application, and it was, I would say, it was masterpiece, because we nailed down like to milliseconds, and it was really great. We absolutely loved it. But the thing was that it not even caused issues, but even troubles for our clients, because no one get it, and it was troublesome. And after we removed it, like all these problems disappeared. And even Facebook had back in the days this brilliant application called Paper, where you can see the news feed, and you can there were like gestures, animations back and forth, and it was really cool. But I even couldn't figure out, and I think that's the reason it's not anymore up. So yeah, you need to really know when it's too much. And core animation is really great and powerful framework for our disposal, and it has really great documentation and APIs. And like hard things, it's really hard to do, I would say. Like simple things, it's easy if we jump back to Soroush code, and it takes quite many iterations to get the outcome that you really wanted. So as Little Prince said in the book, nothing is perfect. So be careful. Like in the beginning, you need to nail down these animations quite many iterations. And yeah, I'm going back home today. So this is Mr. Byte. Always when I'm leaving my home, these sad eyes. So he has been 3 days alone. So I need to go back and feed him. So thank you. I will be available for your questions after this presentation during the event. And if you prefer digitally, here are my details. Thank you.